Hello and welcome. My name is Bhuvan Unelkar. I'm your tutor, and we are discussing business analysis. As you have noticed, I have purposefully kept a cup of tea in my hand to further underscore the fact that I am relaxed and I want you to be relaxed as well as we go through this journey of business analysis together. We are now in lecture 4, which is almost one third of the course. So if you are with me, you're doing pretty well. What did we discuss so far? We looked at first the general introduction, then we defined or tried to define what is business analysis in the context of some known frameworks like the IIBA and the AIBA and the SFIA and so on. In the third lecture, we tried to deal with what is pure business ambiguity, the amorphous, undefined nature of business, and try and understand it through the art of questioning, through the art of listening, through the techniques of mind maps, Ishikawa diagrams, SWOT and pestle analysis, and so on. So that's pure business analysis in decision making capacity, more often than not at the board level. But once we have identified the major areas of work, once we have created a model, once we have created some sort of a description of what is otherwise very messy or undescribable business scenario, we then move to what are the requirements of that particular business or of that particular project within the business. A few years ago, in the mid 2000s, business analysis was more or less synonymous with requirements modeling. This particular lecture is focused on that requirements modeling. But the reason I mention all the earlier bits is so that you know that business analysis now is a lot more than requirements modeling. But when we do start modeling requirements, how do we go about them? We can talk to the users, we can ask questions, we can draw some diagrams, we can put them in case tools, in computing tools. The mechanisms of modeling requirements are a combination. They are a combination of using some diagramming techniques, using some documentation techniques, and then of course verifying and validating those models. You may have come across a very popular term called UML. It stands for Unified Modeling Language, and it's a modeling language. So it's not a programming language, it's less technical and more visual. Now we are not discussing UML per se, but there are a couple of modeling techniques, couple of diagrams in UML that I find are extremely helpful. in capturing requirements, in doing their verification and validation, and then keeping them current as the actual business requirements, business needs change. So there are two really typical UML diagrams that we will discuss. We'll look at use case diagrams, also the accompanying documentation called use cases, and we'll look at activity diagrams, and then I'll also introduce a little bit of alternative diagramming techniques to activity diagram called business process models, or BPMN, business process modeling notations. And you will find corresponding websites and articles on your seminar, in your seminar. So let's have a look at these techniques. These are all techniques to record the functionality of the system, how the system is supposed to behave. And when it comes to modeling that functionality, modeling those requirements, who do you think we should start with? What is the first model? Well, in use case diagramming techniques, we start with the most important, the key model or modeling construct, modeling element, and I'm going to draw it for you. That's it. That's how functional modeling or requirements modeling, as far as functionalities are concerned, should start. This notation is called an actor, and obviously the entire system is there to provide value to this actor. So imagine yourself in a requirements modeling workshop. You are the BA, the senior BA. You are conducting the workshop. There are various stakeholders, the business users, the domain experts, the architects perhaps, the designers, the developers, the QA person. You can have a mix of these roles within your workshop, where you are trying to figure out what are the requirements of the system. You start with the actor. And there is a classic example, the banking example, because you and I have always gone to a bank. For a banking system, a typical banking system, this actor will be your customer. Forgive me for this reverse image, but there's not much I can do about it. You will have many more actors. You can have another actor, and you don't have to put it on the right side. In fact, tools like Microsoft's Visio will do this job for you. And if you have access to Visio, I do encourage you to try it out. Otherwise, we will try some other tools. Or you might simply draw a picture in Word or in PowerPoint. Or you might draw it as I'm drawing and scan it and put it in your assignment. So here is another actor in a typical banking scenario. This is a teller. Now you have started modeling the users who are eventually going to be benefited who are going to have a certain goal to achieve with the help of the system. Once you do that, and many more, you create what is called a system boundary, and your use cases are a representation of what the actor does and what the system does in response. So the first very typical scenario is customer withdraws cash, withdraws an amount. Now if that's the system you are modeling, you're going to create a bubble or an ellipse. That is a use case, and you simply connect these two to say that they are going to communicate, they are going to collaborate to execute customer withdraws cash, and this is your system. And there are lots of variations to this. You also have customer deposit cash, in which customer and teller could be involved. You can also have make inquiry, and you can have customer, if customer is going on the internet, you can have a variation to this. You can also add some descriptive notes, and I have given all of these details in the seminar itself. And that's how you draw a use case diagram. But that's probably a quarter of the effort or even less. This is a good scoping diagram. You will have many more actors here, many more use cases, and you can have more than one diagram. But then consider this particular use case. Customer withdraws cash. What has it got inside it? It has got documentation. It has got details of how customer withdraws cash will be executed. So again, have a look in the seminar, and I have given a template. Now this is typically a Word template, and it will have name of the use case, customer withdraws cash, a description, one line description, some preconditions, some post conditions, and then there is a text or a flow, if you like, a basic flow of the use case. And this is the crux of use case documentation, use case modeling. You got your steps 1, 2, 3, 4, 5. First step in customer withdraws cash is customer identifies herself, teller enters identification details in the system, system validates customer ID, customer specifies amount and account, system validates amount and account, and so on. And in my experience, these statements, these interaction statements in use cases are like those old age COBOL procedure division statements. If you have done, I'm sure most of you have not done COBOL, but I am an old time COBOL programmer, and those are the kind of statements that we put in use cases. So although use cases came about through object orientation in 1990s, they have been popular because they help a business user to start talking to a business analyst and also to a developer in terms of what the business user wants, what the business user in terms of the customer and the teller and the person in the bank who is responsible for the system wants. So this is the documentation. You don't have to create a template. You can use the template given and document a use case or two as required. In practice, in typical banks or telecom companies or insurance companies or airlines or hospitals that I have worked with, a typical small to medium project can have 20 to 25 use cases, sometimes less and sometimes more. Now, this particular flow in the use case, this interaction, obviously you can have exception here because you will say system validates the ID, and then there is a question: what happens if the identification is invalid? And so you write A1 for alternative flow 1, A2 for alternative flow 2, and so on. But this particular text or interaction can also be represented through a flowchart. So this is a flowchart, or this is the description of a potential flowchart. Only thing is, we don't want to call it a flowchart. We call it an activity graph or an activity diagram. And you will find that the BPM diagram, the business process models, are also flowcharts, sometimes drawn going left to right, sometimes going top to bottom. And then there are a couple of things, additional. So you got your customer here, you got your teller, and you have a system. Now system is never an actor, but system is a sort of pseudo swim lane or partition, and we draw these dotted lines to indicate these are the lanes or the partitions in which these actors will be performing their actions. And then you start by customer. You have an activity here. Customer identifies himself or herself. Another activity, teller validates or enters data. Then there is a third activity, system validates whether this is a correct ID or not. And then you have a decision box, as you have in any flowchart. Is it valid? Yes. Teller can ask for more information from the customer. What is it that you want to withdraw? What's your account details? Customer provide that, and so on. So you will find that the description, which is in red, and the flowchart in green, is more or less mapping each other. You can then ask, why do I need to do both? Well, activity graphs can carry a lot more information, and they are also a nice cross check for what you have documented in the use cases. Therefore, in practice, we do both. Then the descriptions lead to identification of key domain entities or key classes, as they are occasionally called. And it provides a nice flow between what the user wants and what the developer can and does provide. So that is a key modeling technique or mechanism to document functionality, functional requirements of the system. An important thing to note is that in each of these cases there are lots of rules that are being applied as the system processes or functionalities move from activity to activity. You can see here already we have put conditions. Is the customer valid? And what makes a customer valid? If this is an internet based application, which it will be, or a mobile application, how many times a customer is allowed to try and log in before his or her ID's password is reset? So there are behaviors, flows, and there are rules that are associated with these behaviors. And again, in practice, we can do it in many different ways. We can create a repository of rules, and then we can apply that repository to these functionalities or function um, models. So that's what really this lecture is about. You will go through the seminar and get more details. You will also see the diagrams properly drawn in their final form, and that way pick up a lot more than what I have shown in these past 15 or 20 minutes. As always, we talk about assignment. So in this particular week, you have already submitted your outline, but you are also reading the outline of the assignments of your fellow students, and you are required to pass comments on those outlines. And you may not pass comments on all of them, but I would say at least five assignments whose outlines are more attractive to you, you should pass comment on. If you pass more comments on other assignments that your fellow students are creating, you will yourself gain a lot more. And in terms of drawing these diagrams, these models also, the more you draw with pen and paper to start with, the more you gain. In practice, in a typical consulting assignment, you will not be drawing it with hands, although you will use whiteboards initially or butcher papers, but eventually they'll go and set these diagrams in a tool. Now, in conclusion, how does one know that all the functionalities have been captured? And you will find various gurus, various experts telling you um, means of deciding whether the requirements are complete or not. I personally find there is no mathematical formula which will say yes, all requirements are done. So it's an iterative process. So you do some requirements, you show them to the users in terms of these models, you do the walkthroughs. As you do that, more requirements come up, and when you reach at least at the end of three such iterations, when you reach a stage where the users are giving you an indication that more or less what they want is being captured, that might be the time when you will get a gut feel that requirements have all been captured. So one indicator is that you have done three iterations, 3 weeks, maybe 3 workshops. Second indication, there are no new roles that are coming up during the discussion, during the workshops. There are no new use cases that are coming up. And that doesn't mean all requirements have been captured, but it means more or less they have been captured. And as you do the walkthroughs of each of them, and you must do walkthroughs after you have drawn the models, and circulate them and get as many people to comment on them, and the domain experts will start making changes, and let them make the changes, let them suggest the changes, and you will find that you have reached a critical point where you will feel that more or less the requirements are there. So it's a combination of using some um, project management techniques, using some iterations, using the capabilities to understand, listen, model, show them back, translate, interpret, and thereby reach a stage where you can say the requirements have been captured. So I hope this has been of value. There is still the seminar for you to go through, and then we will get together during the discussion session, discussion forum, and good luck also with your assignments. And I hope you have been having a cup of tea. I'm going to continue with my cup of tea, and good luck to you all. Bhuvan Unelkar again, your tutor. Thank you very much.